Okay. So in this chapter of gravitational field, we have two portions basically for this chapter. Okay. One contain the gravitational field and the other contain wait, come on. Um, okay. So one contain the gravitational field and the other contain the gravitational potential energy. Okay. So these will going to be the two things that we will going to discuss. Okay. And gravitational field. Okay. So this is the first chapter. Okay. And greater. Okay. Perfect. Come on. Okay. Now, so in this chapter, we will going to discuss some of the contents. Okay. So the first thing is we have to understand the gravitational field. Okay. And then gravitational force. Okay. And then, come on, just a second, please. And I don't want that. I have physics. This one. Okay. So gravitational field, gravitational force, and then um density relation. Okay. Density relationship. Okay. And then we have to do the weightlessness. Okay. And then you'll be doing Kepler's law, Kepler's law. Okay. And then binary stars. Okay. So these are going to be some of the things that we have to discuss. Let's begin. So, sorry, move to trash. So, in the chapter of gravitational field, we first, when we're starting 11th of September, 2025. Okay. So, in this chapter, the first thing is the gravitational field is and the gravitational field is strength. These are the two definitions that we should know. Okay. So, wait, gravitational field. Come on. Um, gravi gravitational field. Okay. So this is the first thing. And then the second thing is the gravitational field strength. So first I have to start with the first concept. Okay. So gravitational field is said or is defined as um so let me just change the color. Just a second. Or let's just go with this one. Okay. So over here we say that it is a um, region of space where region of space where the mass experiences the force. Okay. So in this definition we have to discuss two things. Okay. The first thing is a region of space, and the second thing is the the force, okay, that is being applied on the mass due to that region, okay. And then we have the concept of wait, then we have the concept of gravitational field. Gravitational field is strength, okay. Gravitational field is strength, okay. Field is strength, okay. So in this quantity we define this as force per unit mass. Okay, and if we try to write the formula, so G is equals to force, which is a gravitational force. So I'm writing Fg divided by the mass, which is m. Okay, this is the formula. Okay, and for the unit, it is going to be newtons per kg. Okay, per kg, and it is a vector quantity, by the way. Okay, vector quantity, right? So this is the concept of the gravitational field and the gravitational force, right? Now let's talk about the region of space where the gravitational field exists. Okay, so let me talk about the okay. So we have the region of space. Okay, so let's talk about this one. Okay, so in this region of space, let's assume that I have a planet right here. Okay, and in this planet we are going to have, or we can, okay, we can just copy the image. Gravitation, save my exam, and I think I got a picture right here. I wish, okay, like this one. Okay, just erase it. Fine. So this is how the region of space looks like. Okay, let me just draw it a bigger. Fine, perfect. Okay, so if I have the planet, okay, and I got the field line perpendicular to to the surface, okay, going inward, right? Every field line is going inward. Okay, so and we know that it is a vector quantity, so the direction of the field is basically, or the arrow showing the vector nature of the quantity. Okay, and if you put the object in any at any point, so it will always going to attract toward the direction of the field. Okay, so this is how it looks like, and now we have to understand the properties of the field line. Okay, so let's talk about the properties of the field line. Okay, so properties properties of, sorry, of the field line. Okay, so this is required to help you understand the concept. Okay, right, help you understand how the field line should be, or like how you understand the field line. Okay, so for that we understand the concept of the, or we understand the properties. Okay, that how they interact, or how they actually are. Okay, so um okay, so the first property is the field lines are imaginary. Okay, field lines are imaginary, generally in nature. The first thing. The second thing is field lines follow field lines follow the inverse square law. Inverse square law. Okay. So the inverse square law is basically if anything is like this. Okay. If you have a y, okay, if you have the y-axis and you have the x-axis, okay, and related, y is related inversely square to x, okay. So the graph basically look like this. Okay. So this is how the inverse square law work. Okay. Clear? Okay. So this is the concept of the inverse square law, right? So if you draw the field, if you take the value of the field strength and plot it on the graph, so you'll see the graph like this. Okay. So it will be inverse square law. Okay. So this is the inverse square. Okay. So these are the two properties, and they are very important, by the way. Okay. You have to memorize it. They'll ask you in the paper. Okay. The third thing is, the third property is going to be um, field lines are radially inward, inward. Okay. Okay. So you can see that this nature is basically the radial line. Okay, like the field lines are passing through the center. Okay, of the circle. So this is basically the radial nature of the field line. Okay, so field lines are radially inward. Okay, and inward and and perpendicular per perpendicular um at the surface at the surface. Okay, so field lines are radially inward and perpendicular at the surface. Okay, at the surface of the planet or at the surface of whatever you have. Okay, so yeah, Chajana, just a minute, please. Why not working? Oh, wait. Okay, so this is the third property. Okay, and like agar aap, when you look this closely, so this thing is basically perpendicular. Okay, this line right here will be perpendicular. Okay, so yep, this is the third thing. Now the fourth point is they never intersect each other. Okay, so field lines never intersect each other, essentially. Okay, so whenever they meet, they just repel each other, and but they never intersect each other. I'll show you how they look like. Okay, while they interact with each other. Okay, fine. Okay, we should be C. Okay, and okay, so the two planets will look like this if they're interacting. So let's say this is one mass, and let's say this is the other mass. Okay. And okay, so let me just make the field line for you. Okay, so the field line will be like this. Okay, they won't intersect each other, but yes, it looks like this. Okay, and they create the null point in between. Okay, so this is how the field line. Okay, they will be inward. Okay, and from this point they'll remain the same, perpendicular. Okay, or it could be like this. Okay, and then the field line then remain the same. Okay, like this. Clear? Perfect. So this is the fourth point, and the fifth point is going to be um fifth point, direction of the field lines shows the direction of force on the mass, on the mass. Okay. Um, and the last thing is six. The last thing is the separation between the lines, the lines show the strength of the field line. Okay. What does this mean? This means that if like okay, so if you have the field lines, let's say this is a planet. Okay, and these are the field lines originating from the center. Okay, and they're extrapolating like this. Okay, like this. Clear? And let me just draw some more lines. Okay, now the separation between all the lines will be inward. Okay, the separation of the field line will going to be like this. Okay, so over here the separation is smaller. Okay, and as you move out, come on, as you move out like this, so the separation is larger. Okay, so there will be greater gravitational strength at the starting than at that end point. Okay, so greater strength. Okay, and over here lesser strength, lesser strength. Okay, so this is how and one last thing. Okay, so okay, so the seven is the field lines, the field lines near the the surface of the Earth, of the planet, yeah, of the mass become parallel to each other, to each other, right? And gravity become constant, okay, till the certain distance, okay, till the certain height, till the certain height, okay, certain height. This means if you're, let's say, if you're standing on the surface of the Earth, okay, and let's say this is the surface of the Earth, this is the surface of the Earth, so the field lines appear to be very much parallel, like this, okay. They're not exactly parallel, but they appear that way, okay. I'm not making it like exactly parallel, but um, they are appear as they're parallel, okay. That's very, and the last point, okay. So you can see that they are basically, they're basically converging to a point, but they appear as a parallel, okay. And due to that, the distance d is approximately constant, okay. So the resistance d is approximately the same, so the gravity g will also going to be the same, right? But if you go the distance, like if you go the distance far beyond the surface, then you'll feel like they're not like they're not parallel, okay. Like if this is a planet, like you're viewing it from a very large distance, so the field line will be like this. Oops. The field line will be like this, okay, like this. And in the first case, you are allowed to use gravity as 9.81, but in the second case, you are not. Okay. In the second case, you are not allowed to use gravity as 9.81. You rather have to use a formula to find out the value of G, and then you have to work out for that. Okay. So, like this, and, and, okay. And one more thing, and one more thing. Perfect. Okay, so from the very far end, it looks like this, but from the very near end, it will be like that. Okay, and due to this, you can use the equation of motion for this cases, right? When you are near the surface of the Earth, but when you are far away from the surface, you are not allowed to use that. Okay, use the equations of motion and take G is equals to 9.81 for this case. Okay, but for this case, do not use equation of motion. Okay, motion or G is equals to 9.8, right? You are not allowed to do that, right? So these are the properties of the field line, right, that we have discussed. Now, so this is the first thing that is done. Experiences force, wait. Okay, so this is the first thing. Now the second thing is, okay, this was the first thing, the region of the space that we understand, like how the field lines are and how they act. Okay, and then now we have to understand how the force will act on it. Okay, so let's start that. Okay, so this is the first thing, the second thing. Okay, and the third thing, and the fourth thing. Perfect. Okay, so for now, to understand the gravitational force, we have to understand the Newton's third law. Okay, so to understand the gravitational force, um, or Newton's law of gravitation, okay, let's try with the um gravitation. Come on, gravitational force. Okay, so for the gravitational force, come on, select. Okay. So for the gravitational force, we must understand the concept of the Newton's third law. Okay. And Newton's third law says that if you have the two object, okay, applying the force of equal, if you have the two object, okay, so the two are, and they're interacting with each other by some force. So their forces will follow the Newton's third law pattern or Newton's first law pattern, right? So or maybe Newton's second law, right? So let's say if I have the two planets, okay, or the two masses, okay. So Newton's third law says that whether they're smaller or they're bigger in mass, okay. Or let me take one as a very small mass, okay. Okay. So Newton's third law says that the planet will attract this mass towards its center, okay, and the mass attract the planet toward its center, okay, right. But since the mass is very small, so its gravitational field will going to be very small. So you won't be able to see the effect, okay, of the field, but you rather see the effect of the gravitational force or gravitational field of the planet, okay, or the mass. Clear? So we used to say the five things. The first thing is for the Newton's third law. For the Newton's third law, we should have two bodies, okay, um, and we should have same type of force, same type of force, okay, and then we should have same amount of force, the force, okay, and then we should have um opposite in direction, opposite in direction, and then we can take this as the fifth thing as for the same time, okay. So when these five things will be valid, there will be Newton's third law applied, okay. Now